Hello, everyone. Good evening, good morning, good afternoon, depending on where you are all over the world. Today, we are looking at another series, another part of our series on data analysis, on data science mastery. This is the 80th series of 20. Today, we shall be looking at Python for data analysis part 3, which is to look at data visualization. We want to see what data visualization is all about. We want to talk about those visualizations supported by pandas. Then want to choose the right visualization tools. How do we choose the right charts? Then we look at real world examples. Now, talking about introduction to data visualization, we've done some in during the previous lesson, that is 7 of 20. We considered pandas for data manipulation. We explicitly discussed data analysis using pandas. Actually, the difference between that session and this session is that this session looks at analysis from a pictorial representation, from chart perspective. So we are likely doing the same thing that we did in the seventh video, but this particular video speaks about the charts, the images, the objects, and not the manipulation exercises that we had during the seventh part of the series. We are using pandas because it's a powerful tool. It is a very powerful tool in data manipulation, and it integrates well with matplot library and the other libraries that we use for data presentation. Now, which other reason, you know, is there any other reason why we make use of it? Basically, because it simplifies plotting. It takes away the complexity in plotting. So you don't even need to think of all those complex stuff before you plot your data. There are four basic types of visualization. You can use based on the objects, based on the charts that is of interest to you, or based on the chart that's represent the situation, that represent the data set before you. I'll speak about the first one, which is the line chart. Line chart is for time series data. When we talk of time series data, we're talking about data that are time bound. Temperature is time series because every minute, every second, temperature changes. That is the atmospheric temperature, even the body temperature, temperature generally. It's assumed to be changing at all times. So that is a time series data. Um, Data of that nature or data set of that nature, we represent them with line charts. Line charts. Now we have data sets with categorical information in them. Boy or girl, um, different categories that you can think about. White or yellow, what's yellow, green, as categories of colors, depending on the situation. We represent such quantities. We represent them using bar charts. Now we now have data sets like, say, the individual body temperatures. It is a continuous data set because you can the temperature my temperature could be 49, another person's one could be 48, and another person's one could be 49.2, like that. At the end of the day, you will find out that you cannot categorize temperature. It's just a continuous stuff. So because it is continuous, what that means is that we represent such data set with what we call histogram. Then the last one that I want to talk about today on this part is scatter diagram. This helps us to establish the difference between two continuous variables, just for us to be able to establish whether there is a relationship between them or not. How do we determine which chart to use for what? The type of data determines which of them. If you have categorical data type, it is advisable to look around for pie charts, bar charts, pie charts, bar charts. If it is continuous, you can think of histogram. Then you can think of you can think of histogram. You can think of the scatter plot. That is in a situation whereby you have more than one that you want to find out whether there is this relationship between any two of them. You use scatter plots to do that. But in a situation whereby you have more than two variables and you need to establish whether there is a relationship between them, you still use, well, instead of using any of these ones that were mentioned, it will now be appropriate to use something else, which we call heat map. Heat map combines all the variables and tells and allows you to see the relationship between that exists amongst them all. So after this, we can now go into the basic, the various examples. As mentioned earlier, we shall look at 5 business practical examples so that we'll have proper understanding of what we are talking about. Join me as we go into that session. So this is our Python folder. There's a folder here. I go into the folder and now on this folder, I think there's another folder somewhere which I have created. So and let me grab that folder. The folder is, let's go from our folder. Let's go from the usual folder that we use. Now I want to get my Python from here. All I need to do is click here, cmd, so that my Python can run from inside this folder. So it has brought this. So all I need to do is to type Jupyter Notebook. Yeah, so it has launched our Jupyter Notebook. Okay. Yeah, I need to get the data set that we're going to use for today. I kept them somewhere, so I need to bring them in together. Let me put them together. I think it's inside so desktop. Okay, so let me just drop the folder here. The folder is titled dataset. That is it here. So I can close this now. We have our Python already opened. Okay, so I'll start with new. Okay, so now this is session session 8 of 20. it, you can extend the title. Data visualization. Okay, so I'll give this a title here also. Data visualization using Python. So let's make this markdown. Good. Okay, so the next thing we want to do now is based on what we've done before and the little explanation I just gave about data visualization. On this one, we'll be looking at um, we'll be looking at situations whereby we'll bring in our data here, we'll do some analysis, and we run with them. So that is what we want to do now. Now I have my title here. During the last session, that's session 7 of 20, we looked at a way of bringing in our libraries, and we said that in Python you have to look for the appropriate library that works for the situation before you. So in this case here, I'll be doing something similar. We cannot manipulate data without we cannot present data in a visualized way without manipulating it at some point. So it depends on the situation. So the first step that we need to do is to import our libraries, our pandas as PD, so that we'll not be calling pandas, but we'll just be calling PD instead. Now we need, because we want to visualize it, we need to bring in this library, matplot library dot spyplot as plt. Okay, so I'm going to run this. It's still running now. Yeah, it's concluded now. That's why this is one now. Now the next thing we want to do is this. And I just need to show us some basic plots, see how some things work, then we'll go into our examples. Now let us assume we have a data set that has sales, year, and the sales value for that year. Let's assume we have data in this format. We have the year, and for year we have we have 20, say 2020, 2021, 2022, and 2023. Let's assume this represents the profit of an organization. I mean, these are the years, then the profits made. Let's call that, or let's just say sales for now. We'll come back to profit later. Sales. I'm just trying to give an example. Let's use sales values like 150, 300, 450, 210, 375. These are the profits for each year. We have 150 for 2020, 450 for 2021, and the like. this is our data set, but this data set has been presented in terms of a data frame. This is a data frame. For those of you that must have watched the third or the fourth video, we discussed explicitly about data frames. Now, what we are saying here now is that we want this. This is a dictionary rather. Sorry, apologies, please. Not data frame, a dictionary. Remember, we discussed list, dictionary, tuple, sets, and and yeah, we did something of that nature in the past. So, and dictionary. So this is a dictionary. So we want to make this to be a data frame, to be like a table. So what I'm going to do is I'm going to leave this as it is, and I'll make it a data frame now. I want to turn it data frame in Python is the same thing as what we call table in Excel. It's similar to what we call to table in Excel. So for me to do that, I need pandas. PD, I call data frame, which is inside pandas. I'll just tell data frame that can call this guy, present it to me as a frame, as a data frame. That's all. Done. So let's see, data frame. That's it. So now we've done this before. It's just a recap kind of. Now I want to plot this. What I was saying is, because this represents sales data, remember I had explained this earlier, this is going to be a line plot. Fine, you can make it a bar plot because each year is a category. Each year can be a category, which is fine. But I want to use a line plot for it, just to show the trend. In this case, trend is what is of interest to us, and that's why we are using line plot. So what I'm going to do now is this. I want to do the line plot for this. Let me put it like line plot. So I'll call the data frame df dot plot, just plot, as simple as that. Open a bracket and close it. Tell the system what is your x-axis, tell the system what's your y-axis. So my x-axis is I want to put here this one on my x-axis. Then my y-axis, I want to put this guy sales. We are done. So now tell the system to show it. Now for it to be displayed, sorry, yeah, we have something close to what we are looking for really. So instead of making it display this way, you can come down here and use a matplotlib library to display it by calling plt dot show. If you don't call it, it will still show as we had it before. It's still fine. So even if you don't call it, you just call your df whatever, you just leave this guy this way to still show. Let me go back there. Now this is what we had before, which is still the same thing. So whichever way, right, but this has its own place. At some point you'll see the difference. So what we have now is a simple representation of that data set. Now the next thing that we want to do is to make that data set to be a bar chart. Let's make it a bar chart and see what happens. So all I'm going to do is I'll just call this, let me just copy and paste this guy here, bar plots. So what I'll do now is I'll still have this, but there will be a difference kind of. I need to tell the system to say kind. I'll tell the system kind, that's kind of chart that I'm talking about. Bar. Then put a comma here. If I do this, the system will not show me the lines. Can you see the difference? Because I just placed this guy there. Now I have it in a different format. When looking at this, we can say a lot about the data set. So this is the way it works. If you want, for example, let's say that this one we want to display the scatter diagram. Let's assume we have, remember we have our profit. I'm sorry, we have our sales values. Then we have the year. Now if we want to use scatter diagrams, then we'll be thinking of two things, the profit and maybe the profit and the sales. Let's do something. Let us add to the data set. Add the profit column to df. So how do we add it? I want to add a new column to it. I'll say df profit, just stats. Need to put it in quote. Profit equal to, for each of those year, let's say the profit is 75, 120, 80, 60. And what that profit to is. So if I go to my DF now, you'll see that a new column has been added to it. We've done this before also, so we have the three of them now. So I want to see the correlation between sales and profits. That is when I'll use a scatter diagram. So I'll still copy this guy for my scatter diagram. My scatter diagram, so I'm going to have so I have to change this. Kind is scatter, that's the kind. My x is, let me make my x to be sales, and let me make my y to be profit. Okay, so then yeah, I think we are done. This is scatter here. That's it. These are the dots. You can go ahead and customize, depending on what we want to do. It's just to add more stuff to it. That one is not a problem. So as we get along, we shall look at them one after the other. How do we customize what? How do we change the title? How do we give it this? How do we give it that? And the rest. So what I'll be doing now is that we have looked at explicitly as the four different types, and when you need to customize, all you need to do is to tell the system, this is the title, this is the x-axis, this is the y-axis, give me a grid and the rest. So I'm going to do that to each one of them. So I'm going back to the beginning, to the first one here. Before this show, I'll come here and I'll say PLT dot title, give it a title. Let me call it sales trend. That's the title that I want to give to that one. Or like we can do yearly sales trend. Then plg dot my x-axis, x label, x-axis is here, it's already here, so but just in case you have a situation that you need to determine to tell the system which is which. Then my y-axis, y-axis is what? This is x-axis, this is y-axis, sales. That's it. Now we want a kind of grid, that means lines. So you can tell the system plt dot grid. Just tell the system true. Oh, okay, so I made a mistake here. Label, this is supposed to be label. Yeah, so now you can see the grid. That's the main of this grid here. So we have this, we have this, we have the title. So we can do the same thing for the others also. It's exactly the same way. So I can copy this and bring it down to this one here. Tell the system sales yearly sales values or yearly sales. On the x-axis is here, on the y-axis is sales. Okay, cool. Yeah, we want grid here also. That's it. So same thing here. The only difference here is that this is yearly sales, sales versus profit yearly profit versus sales. So on the y-axis is already there, and the x-axis is sales. It's already there, but just in case you need to add it, then the y-axis is the profit. So we have the title now, we have the grid line and the rest. So basically that is the way of working around that. Now in a situation where we need to group data, you can group your data before plotting is allowed. And so the situation determines whether you need grouping or not. We did all this in the previous during the previous session. So that's in a nutshell is what data visualization is all about. Now we want to start looking at some basic examples, some practical examples, which I think you need to pay a lot of attention to. I'll be using some data sets which has been prepared for this exercise. I've not used the data set before, but at least I just prepared them, generated them before the session. So what we'll be doing now is to consider them one after the other. We want to solve 5 problems. Problem number 1. Problem 1. I think I have the problem written somewhere. Um, so this is the problem that we want to solve. A retail store wants to analyze sales performance over time to identify trends and peak in sales. That is just what we want to do. So this is sales analysis for a retail store. Let me give it a title at the top. Let me move this up. Let's see where it goes to. Move it down. I want it here. Okay, cool. So let me make this a title. I'll say this is number one. Practice. Let me call this problem sales. I'll just call this one. Sales analysis for a retail store. For a retail store. Let's do this. Cool. So then we have the problem here. This is the problem. So this is what we want to solve. We have the data set, so I'll just bring in a data set which is in our folder. Where is our folder? Need to bring this down. Our data set is inside here. Yeah, this is it here. Sales performance. So we want to look at that and see what works. Now let me copy the name. Just copy. Please note that it is a CSV file, comma separated values file. So I'm going to close it. It's inside a folder called dataset, and dataset is inside where my Python. This is my Python file. The dataset is inside it. So now I have to bring up that. So I need to load our datasets. Let's call that. Let's call it the data frame df. It's a CSV file, so that's pd.read_csv. Remember, I copied the name of the file, CSV. Now, because the file is inside a folder, so I need to recognize the folder, otherwise it will not see it. If you do this, let me show you something here. If you do this, you run into an error. Yeah, no such file or directory, because the file is inside a folder. You have not recognized the folder. So the folder is datasets. Now we are good. Let's see the first 5 records in the dataset just to tell us we are actually there. Oh, cool. So we have the region, we have the month, we have the sales. So we can do several things with this. You can do is this sales store? This seems to be performance. Where is the sales store? I think I've picked a wrong data set. This is performance, but anyway, it's okay. um yeah, we'll do region is, yeah, then again sales, so we are still good. All right, so now what we want to do is we want to visualize this. I'm not doing any manipulation or whatever. I just want to visualize, because the subject, our deliverable for this session is visualization. Now for me to visualize this, I want to plot I want to do I want to plot region against sales. That tells me what's going on in each region. Okay, that is possible. And for this same one, we can establish the trend. It's possible. So all I need to do is come here. I can grab this. This same code that we used there, df.plot kind equals, it depends on what we want to achieve. We just want to analyze this performance, and in doing that we can do that by month. If we do that by this month, that means we are doing trend analysis. That is no longer bar charts. That one is now something else, which is scatter diagram, which is line graph. So what exactly do we do here? Let's do two things. Let's do line graph first. Let's do line graph because we've not done that one before. So I'm going to tell the system to say my x-axis, I want my kind first is line. I want line graph. Then let's have x-axis to be, everything is in the same year, the month. X equals month. Then y equals sales. Yeah, sales. Okay, then we need to tell the system the kind of marker that the system should use, which we didn't use in the other side. Use small o, like dot, as marker. Now what happened here? df.plot, yeah, kind equals this. Even if you don't include this, you'll still be fine. What happened? Yeah, positional arguments. Okay, we'll come back to this one. I want us to do, let's do the type we did before. Let's do bar. Our x-axis is region, then sales on the other axis. Oh, y-axis. I left out this. That was a problem. So if I run this, There'll be a challenge. Yes, I expect this challenge. You know why? We have a lot of nodes. So to plot this, you will need to first summarize before plotting. So we have not told the system. Okay, wait. Let's do this. The system should do it. Then coming automatically. Let me check something. Oh, okay. Yeah, yeah. We have a lot of north, like I was saying. A lot of north, a lot of south, a lot of east. We don't want to see this. We just want to see one south, one north, one east. So what that means is that there is need for us to do what? To to group the whole thing. So we need to group the entire stuff. So after grouping the data, then we can now say this is this, this is this. So we can group this by month, we can group this by this. So if for example we want to group by month, we can say df dot plot subplots equals to what kind of layout? I want 1, 1. You can change this as you like. What is the figure size? Fig size is what do I call it? What do I use this for? Let's do 8, 6. Then that's it. But this is not where I'm going really. But what I want to do is to summarize the whole thing. So I'm going to summarize this whole thing to say df grouped equals df dot group by. You tell the system what you want to group it by. I want to group it by year. Then after grouping it, sum for each group. So when I'm done with this, let me show you this first. What happened? Year. What's the year there? Oh, it's region. Sorry. We want to group by region. Yeah, that's it. So if I pick this now, I run this one here, you can see that we have the data by region now. We have the east, west. I'm not interested in month. I'm only interested in these two. I could have taken these two out, but I'm not interested in that one now. Anyway, so now that we have this, we can plot this with bar graph. So we can now say that we have the grouped data, this guy, and do a plot. Tell the system kind equals bar. You can tell the system about your x-axis. I want my x-axis to be sales. Then I want my y-axis to be, I want to do something unusual. I want my y-axis to be region. all I'm trying to do is to produce something of this nature. So I have my cells, I have my region, I run this. Is it not region? Did I miss something? Region. Yeah. Because if I plot without, so if I plot, say I want to plot this, see what the result will be like. Because the system is aware of this, but I still want to go ahead and specify. So that's the difference. But I just want to see what happens. The system is aware that I can plot this one, so it picked this and this. So you can go ahead and include the title and all those other things to it. So from here you can analyze the figure. You can analyze the position of this of the map of the store, which is easy. Can do the same thing with the months if we want, and at the same time we can do scatter plot with months. Yeah, you can do something similar with the months, which is the same thing. So where did I use scatter? Yeah, you can use this for the months. But I want us to trend the line. So I'm going to use, where is it? I'm going to use this guy, but this time around I want to trend it. I want to use the month. So what I will do is I'll call this line, then on the x-axis I want to use months. On the y-axis I want to use sales. That's it. So this is a trend line that shows how the data moves. Now the implication of this, what we are seeing here now, is that at this point here the profit is very high. In fact, it was the highest here. This is not too far from here. The company experienced a very low profit around this time. You can increase the size. You can give it a figure size, and you can do PLT here at the same time. PLT to give you the same thing. PLT dot show to give you the same thing, and you can now add figure size and all those kind of thing to get something bigger and better. It depends on how you want to look at it from. I can do my own figure size. My own figure size could be, let me see, I don't want us to do figure size here really. 8,6. Oh, sorry. I don't want something complicated for now. I just want to keep it simple. Just for you to see as we get along, we'll be seeing some other things. So this gives us a position on that data. Now, if we decide to say we want to write this in another way, the system will do it. The system will do it. We can do anything we like with it, and we'll still have our result. So it depends on the ask, that is the question that is before us. Aside that, there is, I cannot say that there is anything that we cannot do. We can do almost everything with the data. So that ends this one here. Now the second instance as we is on customer segmentation. So what I'm going to do is, for the second one, please note that we are just playing around to understand customer segmentation. We are just playing around. This is number 2. So the problem to solve here, I think I have it somewhere here, is this. Customer segmentation. So I need to go back to the folder where we have our data sets. There is a data set on customer segmentation. This is it here. So I'll pick this, just copy it, then I close it back. Now I need the data, df equals pd dot read underscore csv, because the data set is csv. So I have this here, dot csv. Now we need to, now pointing this to the dataset folder. So we're good. Now let's see our data, the first 5 records. Okay, so we have segment, age, income, spend. So we want to segment this market. We have their spending habit. We want to divide the customers into different segments based on their spending habits. So what do? We use a chart. So to solve this problem, I'm going to do df annual spend. Do I want to do annual spend? I will do spend. I'll tell the system to plot the spend. But what kind of plot are we looking at? Histogram. Kind equals histogram. Then we need to talk about the beans. Let's do 5 for now. We can change it later. Then the edge color, we want our edge color to be, let's do black for now. We can come back and tweak it at some point. I want this to be full. Let me run this first. Yeah, that's it. But I want to give it a title, plg.title distribution of customer spends. So the title is distribution of customer spends. I want the x-axis plt.x label, x label. On the x-axis is the spend. That's the spend in dollars. Then my y-axis, that is the number of customers. Let's put a grid there. plt.grid equals true, then show plt.show. Yeah, so that's it. So from here it is clear that we have quite a chunk of customers spending between $0 and $1,000. That's where we have the highest. So I want to believe these are the low guys. Then we don't have any customer. We have almost zero, if not zero, customers spending around 4,000. That's between like 3,200 to something around 4,300. Okay, so for this organization, it is better to, if the organization is looking at bringing in new customers or ensuring the customers, the existing customers purchase more, there will be need to target these people, these ones in this segment here. Then the advertisement that needs to be done could be a two-way thing. There could be one that will allow these people to retain. You want to keep them so that you don't lose them. Now there will be another advert that will take care of the people in this band. So this helps the organization to allocate resources and marketing budgets. Now the next one is the next practical example is on employee performance evaluation. Employee performance evaluation. And the problem that we want to solve here is simple. We want to evaluate employees' performance across different teams and identify the top performing teams. That is what we want to do. So let's grab the data. Employee productivity, I think it's this one here. df equals pd.reach underscore csv excuse me, data sets. Now what kind of data do we have there? Okay, So we have department, employee type, age, hours worked, productivity score, and the rest. So what we can do is we can do productivity score, can plot that by departments so that we'll see, because the question is how do we identify the top performing teams, so that means the departments. Okay, so now to do this I'll just copy this guy. It's the same thing, it's the same thing. Kind is histogram, yeah, it's histogram because the productivity score is continuous, that's decimals. um Here edge color is black. Let me use edge color to be blue, to be red for you to see. Then distribution of productivity scores. On the X label we want to do productivity score. No. Oh, this is not times 3, this is supposed to be bar, so we don't need this guy. But productivity is histogram, is histogram. X label, let's have the teams there, department, because if we don't have all this, let me just put department and then let's run this, then we can come back and find it. Is there no spend? Oh, productivity score, where is it? So what we're going to do is, let me remove this guy. Okay, then do my y, the kind is this, my y axis. My y axis is my score, this one here. So this is productivity score. My x-axis is so since I have that, yeah, that should be a department. Yes, that's it. But because I want to calculate the score by department, so I have to turn this to bar. This has to be bar. Let's see. Oh, there will be a mistake. I'm supposed to have removed bin. There is no bin in bar. Okay, so um, let's do color here. Sef. Color equals green. Do we use green? Edge color is red. didn't define my x-axis. X-axis is department. Okay. What happened? Yeah, because of the performance score. We have, yeah, we can do normal bar charts. But this is just 5 records. How many records are there? Let's check. df dot shape. Oh, 500 records. I see. So we need to first bring these guys together because we want to find the top performing teams. So we need to do what we did here. Where is it? We need to do what we did. Yeah, we need to use group by. So I'm going to group it before plotting. So what I'm going to do here, I'm going to insert a different group by what now? Departments. So if I call this guy now, let's see what we have. There'll be a problem. I expect a problem. Yeah, a problem here because I did not separate what I wanted. Just pick only those ones, these two. So what I should have done is to separate that, then make this average and not total. So it's just to come here and say this is average AVG. Okay, yeah, I'm using group by sum. Okay, so if I'm using group by, using hour works, using age and the like, so I can pick all those other ones. Again, the way we group by this, you can group by employment type. It's just to copy this guy this way, change it to employment type instead. This now becomes this. That's by employment type, contractor, full-time, this, da 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 da. So I want to believe we can do the plotting of these ones, bar charts of these guys. Just the same way we plotted this. Where is it? Yes, this one. Same way, because here we want to see the performing team. If I do this now, it will take this guy. As in terms of the cost I'm using, so I need to differentiate group by what now? This is group by department. The department. No, this is employment type. Employment type. That's this one. This is this. Yeah, so that's employment type. So this is this one. Now to answer the question, which departments perform better than the other, we can use that here. Can take out this one. So that we can see. So what we need to do is to plot this one instead of this employment type. Is to plot department df. Let me call this df department. Then to run this, then run this. Okay, it's here already by department. So let's have this one here so that we plot. Just carry the plot here and drop the plot here. Same thing, but what is changing is just this guy. So in terms of score, you can see the performing departments. Instead of sum, you can take average, whichever way this department seems to be performing better than the other ones. So these are not serious stuff. We're just playing around with what we have so that we have some basic understanding of what is expected. Now, the next thing that we want to do is that we want to consider another example. This time around, it has to do with inventory management. It has to do with inventory management. Now, with the inventory management, we want to solve that problem of stock. I think I have a problem somewhere here. A manufacturing company wants to optimize inventory level by identifying products very important. So this is inventory management. This is inventory management. So then we have the problem here. You have the problem there. Then what we want to do now is we want to analyze what do you call it, the stock level for each product. Now to do that, we'll first analyze the stock level for each product, then that is over time. Then we'll now try to identify the stock out dates for all products, the future stock level for each product. So let's first identify stock out for all products. Then we'll come back and do forecast on the future stock level. So now, in order for us to do this, we first need to write the code, which is not different from what we have already. Now let's get our, where is it, our data set. This one, inventory management. Okay, go to pd.read underscore csv .csv. So let's point to the direction of the datasets folder. What kind of data do we have there? Okay, stock level, date, and product. Okay, so this is cool. So now that we have this, now the next thing we want to do is we want to find out about the stock levels. That is the next thing that we want to do. We're going to plot it. We're going to plot the stock levels. Then we're going to plot the other one also at the same time, so that we'll see the difference. The first thing we're going to do is to convert the dates, these dates, because let's check first. df dot d types, sorry, product is object as categorical. Can say the date is an object, it's supposed to be date. So we did this in I think in the last lesson, the last session. So I want to do that here now. So what I'll be doing is I'll do my df date, that date, that is this date here. I want to convert it to from categorical to date proper. So pandas to date time. Now what are we converting? This guy. That's the guy that we're converting. So we're converting the guy to date. That's basically what we want to do here in this first part. So when we're done with that, we're now done. So let's check. Good. So we now have date time 64, which is fine. So this is what we want. Now the next thing that we want to do is we want to find out the stock level over time for each product. establish the stock level for each product over time. That's what we want to do next. And how do we do that? Let's first get plt dot figure, our fixed size. Let me use 10. 10 is too length of 10 and maybe 6. You can adjust it when we get there. This is the size of your chart. Now now tell the system for every product in df, for every product there that is unique. You want unique. What do we want the system to do? Give us a data for a product data. Let's call it product data. Product df equals our df df again product if we use products directly, we should, because what we're trying to do, I need us to understand it properly. We want to find the stock level over time for every product. So what I'm going to do is we'll say that this is equal to product. Remember we said product for every product in this. Yeah, so product. So we've done that. For those of you that this is new to, please check the video on I think 5 of 20, where I explained everything about if else, conditional statements, plots. So we want to plot the product data. Yeah. Now how are we plotting it? Using date. Then product df stock level. Stock level. So as it is now, where is that? Product data, product df Oh, okay. I think it is it here. fixed size should be equal to yes, something of this nature, because I have so many products. So what I can do here is, let me put a marker to be O, then and put a label product. Now I want us to customize the plot. This is now for every product. Now for us to customize it, you can put your date and all those other things there. Title, X label, Y label. So let's customize it. I'll put that here. Let me put that here. plt.title. Stock level analysis. Let me just use that, just need anything there. plt.x label dates plt.y label stock level that's it. So let's slant these guys. So I'm going to put something here to slant them at 45 degrees. plt dot x tick rotate at angle 45. Use the x-axis to be slant now. X tick. Where is it? This is X. Yeah, so you can now see as 45 now. Let's increase the size of the object to 10. Let me make this 10. I'll make it 12. Yeah, it's wider now. Okay, so what else do we need to add to this guy? Do we need grid? Nah, it will be too clumsy. Let's try a legend. plt dot legend, and the title of the legend is product. So we have the legend now. So product A, B, C to D. Okay. Then to keep the, then we have let's start. We don't need this really, but layout. Then plt dot show. Okay, so I think we're good now. So this has given us the directions, the stock levels for each product, and those are the dots that we have there. Now we need to be able to predict this is future stock level. Then we need to show the stock trend for a specific product. Yeah, so I think this is cool. It's cool now. So uh, yeah, we want to do another thing with it, because for this product now, this is the level. Product A, this is as at this date is here. As at this date, yeah, because the products are many. It's blue. This is blue. Yeah. So I think it's here. Yeah, depending on what is of interest. So the products are many. So we just want to see the stock level analysis, because the problem we want to solve is to identify products varying demand pattern. It's just the pattern that is of interest to us. So this is the pattern here. This is the way the stock is being what do you call it? Um, is being impacted upon, which we can't interpret as a demand pattern also. You can have different ways of making this happen depending on what is of interest to us. You can have it in another form which will give us the demand pattern. It's just going to be this rough also over time. Okay, now the next example that we want to do, which has to do with finance. I think that's the last one we want to do for today. That's talking about financial performance of a firm. So mark down. Okay, so what's the problem to solve here? We just want to see, I want to analyze profitability. So I want to analyze profitability over time for the assets. Now, in this case, there is, I think I have a different data set. I think, yeah, I think I have a different data set for this. I have the financial performance data sets. So what I'm going to do is I will leave this for the next exercise, because I don't have the data for it at this time. So we've gone through some visualizations just to let us see how those things happen. Join me in the next video. We shall be looking at data analysis using Python. This time around we shall look at extensive example which you consider end-to-end analysis involving everything that we have done in the past. Thank you. Should there be any question, please feel free to drop a message for me in the YouTube session, in the comment section. If there is any area that you need me to talk about or to reiterate on, please do not hesitate to put them in the message box. I will try as much as possible to make them available. Thank you.